In this video, we're going to look at the difference between linear and non-linear rules, and in particular, how to recognise a non-linear rule from an algebra table. We have two algebra tables here. If we look at the table on the left, can you recognise whether this is a linear or a non-linear rule? If you're not sure how to do this, what you should always look at is the numbers in the Y column. And what we look at particularly is whether they are increasing or decreasing as you go down the column, and if they are increasing by the same amount each time. Now, if I look at this table, I can see that from 2 to 5, I'm increasing by 3. From 5 to 8, I'm increasing by 3. From 8 to 11, I'm increasing by 3. From 11 to 14, I'm increasing by 3. So straight away, I can see that the Y values are increasing by the same amount each time. They're increasing by 3 each time. So therefore, this is telling us that this is a linear rule or a linear relationship. Remember, when we are determining the rule for a linear relationship, the first thing we look at is these numbers down here. Because remember, these numbers tell us the multiplying number in our rule. This is telling us that if I want to find y, I first of all have to multiply x by 3. Then I look at x is equal to 1 and I remember my 3 times tables. 3 times 1 will give me 3. But I've got 2 here. Do I add or subtract to go from 3 to 2? I subtract, and I subtract 1. So this tells me the rest of my rule is times 3 minus 1. Let's check if that works on the other x values. 2 times 3 gives me 6. 6 minus 1 gives me 5. 3 times 3 gives me 9. 9 minus 1 gives me 8. 4 times 3 gives me 12. 12 minus 1 gives me 11. 5 times 3 gives me 15. 15 minus 1 gives me 14. So that rule definitely works. However, we write our algebra rule slightly differently. We write it as y is equal to 3 times x minus 1. Remember, with a linear rule, x is on its own here. In other words, it is x to the power of 1. Here we have a linear rule. Now, let's look at our next algebra table on the right. To check whether this is a linear or a non-linear rule, again, I'm going to look at the numbers in the Y column and check to see if they are increasing by the same amount each time. From 1 to 4, we go up by 3. From 4 to 9, we increase by 5. From 9 to 16, we increase by 7. From 16 to 25, we increase by 9. So we can see here that our Y values are not increasing by the same amount each time. So this is definitely not a linear rule or a linear relationship. This is what we call a non-linear rule. Now, the other thing that we need to think about now is what would the rule for this table be? Now, to give us a clue, when we look at the numbers that our Y values are going up by each time, they are different, but there's a pattern here. In the first difference, we can see that the numbers are going up by 3, then they're going up by 5, then they're going up by 7, then they're going up by 9. This means that what my numbers are going up by are increasing by 2 each time. When you can see this type of pattern where the y values are going up by a different number each time, but there is a pattern in the rule, like this one, it means that my rule is going to be a quadratic rule. This is what we call them. We call them quadratic. A quadratic rule is a particular type of non-linear rule, and it means that when we have a quadratic rule, my rule always starts with x squared. A quadratic rule, instead of just having x in it like it did over here, we have x squared. Now, the first thing you should do when you see a table like this is to check whether y is equal to x squared is the rule. So, when x is equal to 1, 1 squared is equal to 1. That's correct. When x is equal to 2, 2 squared is equal to 4. That's correct. When x is equal to 3, 3 squared is equal to 9. That's correct. 4 squared will give us 16, and 5 squared will give us 25. So this is our rule for this table. Y is equal to x squared. Remember, this rule is a quadratic rule and it's a special type of non-linear rule. Thank you for listening.